Okay, so today I'm going to show you guys how to do the second derivative test to find your max and mins. So something important to remember is that if the derivative of a is equal to 0, then the second derivative of, and if the second derivative of a is smaller than 0, then point A is going to be a maximum. And if the first derivative of a is 0 and the second derivative of a is greater than 0, then point A is going to be a minimum. Now, for the first example, we're going to have the function f of x is equal to x cubed plus 6x squared plus 12x. So the first thing we're going to want to do is find our first derivative so we can find our critical points. X squared plus 12x plus 12. Now that we have a first derivative, we're going to want to set it equal to 0. And then, so we can factor that. And then we can factor that even more. And now we're going to be left with x is equal to 0 and negative 2. And these are going to be our critical points. So let's set these aside. Now what we're going to want to do is find our second derivative of f of x equals x cubed plus 6x squared plus 12x. And then we're going to want to go ahead and plug in each of our x values to it and see if it's greater or smaller than 0. So let's start off with x equals 0. So we know that the second derivative of f of 0 is going to be equal to 12, which is greater than 0. That means that 0 is going to be, if we go back to our main point of it, that means that that 0 is going to be a minimum. And now we're going to go ahead and test out x equals negative 2. And then we're going to see that this is going to equal to 0. So because this is going to equal to 0, we know that x equals negative 2 is going to be neither a min nor a max. So it's going to be nothing. Okay, so now I'm going to go ahead and show you another example. So let's say our second example is 4x cubed plus 3x squared plus 8. So again, we're going to want to find our critical points first. So we're going to find the first derivative of this. And then we're going to want to set it equal to 0. So then, and we can factor out a 6x. And then we're going to be left with x equals 0 and x equals negative 1/2. So we're going to go ahead and set our critical points aside. So now that we set those aside, we're going to go ahead and find our second derivative. We're going to go ahead and plug each of our critical points in one by one. So f double prime of 0 is equal to 24 times 0 plus 6. And that's going to give us 6, which in the end is going to be greater than 0. So we know that it's going to be a minimum at x equals 0. So now we're going to go ahead and set our x equals negative 1 into our function. So f double prime of 1/2 is equal to 24 times negative 1/2 plus 6, and it's going to be negative 12 plus 6. I'm going to be left with negative 6. So we know that this is going to be less than 0, so we know that negative 1/2 is going to be a max. And that is how you use the second derivative test to find your max and mins.